Welcome to another video where we're going to discuss some biology questions in molecular biology and cells. So let's start. Question 1. Identify the false statement. So by the way, here we're going to have option 1 up to 6. And option 6 is I don't know. So every question in this case is going to have this option. The reason why we have that option is because there is negative marking. If you get a particular question wrong, you attract a negative 1. So if you're not sure of the correct answer about a particular question, you better go for option 6, which is going to help you carry a 0 rather than getting it wrong and you have negative 1. You can imagine out of 100 questions, let's say 50 of those you guessed and you so happen that you got them wrong, you're going to have negative 50, which is going to have a huge negative impact on your results. So you can go for option 6, I don't know, to be saved from negative marking where you can get a 0. So question 1, which is saying identify the false statement. So meaning that all the four of the 5 statements here are true, but there's only one which is false. So 3s orbitals, the 3s orbitals is the lowest energy orbital in the similar energy shell. So let's do this. So we know to say that the ground state or the electronic configuration that we have here, we have 1s, then you are going to have 2s, 2p, then you have 3s, 3p, 3d, then you have 4s, 4p, 4d, 4d, and then you have 4f, I'll end there. So when it comes to energy levels, so energy levels increases as the shells go higher and higher. Okay, as you move from one shell to the next, the energy level increases. So we're going to have this. Okay, so we are going to have here, this will be the energy level is increasing in this direction. That is an energy level which is far away from the nucleus is going to have high energy. Okay, so we're going to have a nucleus. So you are going to start with the 1s. So that 1s, you know that the s orbital only has got a single orbital. The 1s has got a single orbital. That will be 1s. Then you are going to have 2s, one orbital. Then the 2p. The 2p is slightly a bit higher than the s. And the p orbital has got 3 shells, just like that. Then we are going to have next will be 3s with a single orbital. Then you are going to have 3p with 3 orbitals. Then next will be 4s with a single orbital. Then you have 4p with these. Okay, so this is what is happening. So the statement A was saying that the 3s orbital has lower energy as compared to in the same energy shell. So these 3s and the 3p, they are in the same energy shell, but their levels, the energy levels are not the same. This one is slightly slower. The s subshell is always a bit lower than the p sub level in the same energy shell. That is what you should know. That is why I'm presenting wherever you see the s is slightly lower than the p. So it is true. The first statement is true. The 3s orbital is the lowest energy orbital in the similar energy shell. That is as compared to these other shells, the 3p and the like. 2 is saying the 2p orbital is higher in energy than the 2s orbital. This is true. This is concurring the first statement. The 2p is higher in energy levels compared to the 2s. So the 2p is slightly higher than this, which is true. Then 3 is saying there are 3 2p orbitals in the second shell. There are 3 2p orbitals in the second shell. So where is the second shell? The second shell is this one. So it's saying that there are 3 2p orbitals. So it is true. We have got, this is a p sub-level. How many orbitals do we have? 1, 2, 3. So it is true. It is a true statement. Then 5 is saying the 1s orbital does not belong to the second shell. I think I've skipped 4. There are three 3s orbitals in the third energy level. There are three 3s orbitals in the third energy level. So the third energy level is this one. Do we have 3s orbitals? No. So one thing about the s orbital is that the s sub-level is that its owner has got a single shell. So the s orbital, you will not see something like this. It is on the p which has got 3, the d has got 5, f has got 7, the s has got on 1. So 4 is the fourth statement there. So 4 is the fourth statement. There are three 3s orbital in the third energy level. There's on 1 s orbital in the third energy level. And this is in each level, energy level, there's just a single s orbital. You should know that. Then 5 is saying the 1s orbital does not belong to the second shell. So the number in front of each of these levels, it indicates the energy level in which that one is. So if you have 1s, it means that this is the first shell. 3s, that is the third shell. 2s, that is the third or the second shell. Just like that. So 4 is the fourth statement. Hence is the answer. 2. The valence electrons represents elements. The valence electron of representative elements are, so valence electrons, we know that these are the electrons which are found in the outermost shells of an atom. These are electrons that are found in the outermost shell of an atom. So if you have just a single electron in the outermost shell, that is a valence electron. And the valence electron number is going to be 1 if they ask for the valence electron number. You just count how many electrons are in the outermost shell, that is the valence electron number. But in this case, the question is just asking about the valence element. The valence electrons of representative elements are 1 in the s orbitals only. So the valence electrons, it's not always that they can just be in the s orbital. No, so it's a first statement. 2, located in the outermost orbital. So outermost orbital and outermost shell, these are two confusing statements. Outermost orbital, it may mean different from the outermost shell. We have said that the valence electrons are found in the outermost shell. This shell is the one which contains now the sub-levels which we call orbitals. So in short, we don't have outermost orbitals, we have outermost shells. What we just have in those shells are the sub-levels which we call the orbitals. So no outermost orbital, false. 3, located closest to the nucleus. So valence electrons, they are the farthest from the nucleus. They are far away from the nucleus. If the nucleus is here, let's say a particular atom has got 3 shells, it means that the valence electrons will be very far from the nucleus. So they are not the closest. Then 4, located in the outermost shell. Yes. 5, located in the innermost occupied shell. So outermost, not innermost. Innermost, this is going to be the first shell, which is just close to the nucleus. So that's not true. So the correct statement is option 4, outermost shell. 3, identify the statement that is not correct. So we're also looking for the first statement. 1, for hydrogen atom, the energy of the 2s orbital is lower than the 2p atomic orbital. Do we have 2s orbital in the hydrogen atom? No. So the hydrogen atom, its owner has got 1s. Why? It's because it only has got a single electron. So you just have 1 electron there. And the electrons, its electrons of hydrogen will end in the first sub-level, the 1s. They will not go into the 2s. Okay? So, which statement is not correct? So already 1 is not a correct statement, because we don't have the 2s atomic orbital in the hydrogen atom. Then C is saying, for carbon atom, the energies of the 2s and 2p atomic orbitals are different. The energies, so here, you can see that they both start with 2. What does this mean? It means that they are both in the second shell. So they are both in the second shell. Then we are saying that the 2s, the energy in the 2s is lower, is different. The energies of the 2s and the 2p atomic orbitals are different. This is true because from this we said that the 2s will be slightly lower than the 2p. So the 2p is going to have high energy as compared to the 2s, as this diagram explains. So they have got a different energy within the same shells. So that is a true statement. Then we have option 3. Option 3, which reads, for the oxygen atom, the energy of the 1s atomic orbital is lower than the energy of the 2p orbital. I think this has already been explained. This is true. So the 1s has got the lower energy as compared to the 2p there. Then 4 is saying, for any atom, the 3 2p atomic orbitals are degenerate. So they are degenerate. So you can see that each shell here has got the 2p orbital. So degenerate, this has to deal with any atom can take up any of these atomic orbitals as long as it's in the 2p. So using the Aufbau principle, you fill these like this, then you come back like this. So they are indeed what? Degenerate. So option 3 is also true in the 2p because the p orbital, which has got 3 atomic orbitals. So the 3 atomic orbitals are degenerate, which is true. Then an atom with more than 2 electrons must use higher energy orbitals. That is true. Higher energy orbitals, more than 2. So you're going to fill this one with 2. If you still have some more electrons, you jump now to the 2s. So they have to fill the higher energy levels as compared to the first one, which is a true statement. So the only false statement there is a statement regarding hydrogen, which is a statement 1. Hence, it's the correct answer. Question 4. The lone pair of electrons in water are in the... So what is a lone pair of electron? Oh, what is a lone pair? Yeah, lone pair of electron. So a lone pair of electron, this is a lone pair. This is a pair of electrons. I want you to understand. So I'll use the oxygen. Oxygen, you know to say that oxygen has got electronic configuration 2, 6. Okay. So during the formation of water, it is these electrons in the outermost shell which take part in during that bond formation. So we only have got 4 electrons out of the 6 which take part in that bond formation. So we on 4 or the 6 will take part in that bond formation. So a lone pair of electrons, this is if I add that is a lone pair. If I have got this, that is another lone pair. So you have got 2 electrons together, that is a lone pair. Okay, so if I say I've got 2 lone pairs, it means I've got 4 electrons, because this is a lone pair on its own, this is a lone pair on its own. So one lone pair, another one lone pair, bring them together, you have got 2 lone pairs. How many electrons in total? You have 4. So that is a lone pair. So when you hear a lone pair, that is just a pair of electrons. So the question is, a lone pair of electrons in water are in there. So a lone pair of electrons, they come from oxygen and not hydrogen. Why do they come from oxygen? Because the outermost electrons of oxygen, they are 6. And all the 6, only 4 take part in that formation. Sorry, not 4, only 2. Only 2 take part during the bond formation in a water molecule. So you have that hydrogen here, another hydrogen there. So 2 electrons, one from there, 2 electrons of oxygen will take part. You remain with 4. These 4 are the ones which are going to form lone pairs there. So you're going to have 2 lone pairs on the oxygen atom. So the lone pairs in a water molecule are in the oxygen atom. Now what is this question asking us? So it's saying a lone pair of electrons in a water molecule are in the 1s orbit of hydrogen. No, so they are in the oxygen, not hydrogen. So hydrogen out. 1s orbit of oxygen. No. So if we use this, we're going to find that in which 2p. this one, another one, then 1, 2, 3. So you fill with 2 here, you remain out of 8, you remain with 6. Another 2, you remain with 4. So 1, 2, 3, 4. So the lone pairs are in the 2p orbital of oxygen. That has to be the answer. 1s orbit of oxygen, no. 1s and 2s orbitals of oxygen, no. So they are all in the 2p because the lone pair is formed by these electrons of oxygen, 4 of those. Then 4 is saying 2p orbitals of oxygen. So this is a true statement. 2s and 2p orbitals of oxygen, no. So it's just the 2p. So the correct answer there is option 4. Hope you are able to follow and understand. Question 5. Phosphorus has atomic number of 15. Therefore, its valence is so the valence of an atom. So a valence electron number is different from just a valence. So what we do is that an atom which has got more than 4 electrons in its atom's shell, to find the valence number of that atom, you subtract from 8. So we're going to say 8. You're going to say 8, let's say 8 minus 5. Then you're going to get a 3. It means that the valence of that particular atom is 3. Okay? But if they ask for the valence electron number, just count how many electrons are in the atom's shell. That is the answer. When they ask for the valence, like in this case, if you have more than 4 electrons in the atom's shell, or that particular atom, you subtract from 8. Then what you get, that is the valence electron number. So 15 electrons. We have to come up with the electronic configuration, which is going to be 2, 8, that is 10, 5. So we can see that the valence electron number of phosphorus is 5. But what is the valence now? Since 5 exceeds 4, we are going to say 8 minus 5. So we'll get 3. Therefore, the valence of phosphorus is 3. So that's the answer there. Okay? That's what we do. Then question 6. An atom of sodium with an atomic number of 11 and mass number of 23 has dash protons, electrons, and neutrons. So we have sodium. So they're saying that atomic number is 11. So atomic number is the same as proton number of 11 and mass number of 23. The number of protons. So protons is equivalent to electron number. Number of protons is the same as the atomic number, so 11. So we're going to have 11 protons. Electron number is also equal to the number of protons, another 11. The neutron number, you subtract mass number, you subtract the atomic number from mass number. So to get the number of neutrons, we're going to say 23, which is the mass number, minus atomic number 11. So we're going to get 12. Therefore, we're going to have 12 neutrons in the atom of sodium with a mass number of 23 and atomic number of 11. So the answer has to be 11, 11, 12. 11, 11, 12. So question 6, the correct answer is 3. 7. The third shell with 9 orbitals can hold up to dash electrons. So the third shell with 9 orbitals can hold up to dash electrons. So what you should know is that each atomic orbital can hold a maximum of 2 electrons. Can only hold up a maximum of 2 electrons. So like the way we had the 2s, the s, we said that this one has got a single orbital. The p has got 1, 2, 3. Then the d has got 5. 1, 2, 3, 4, 5. Then F has got 7. 1, 2, 3, 4, 5, 6, 7. So each one of these atomic orbitals can hold a maximum of 2 electrons, just like this. Meaning that the p orbital can hold a maximum of 6 because you have 3 orbitals. So each of the 3 will hold 2, so you have 6. The d can hold a maximum of 10. That is each one, because it has 5 orbitals, so each one of the 5 can hold a maximum of 2. So 2 multiplied by 5, you get 10. So in this case, we are saying you have 9 orbitals. How many electrons are you going to have? So 9 orbitals, we are saying that each of the 9 can hold a maximum of 2. So you just say 2 multiplied by the total number of orbitals, which is 9. So you're going to get 18. So the answer is 5, 18. As simple as that. Then question 8. Question 8 reads, the character of p orbitals which determine the character of atom is so the p orbitals has got planes. It has got the px, the py, and the pz, like that. So it is like this, like the x or y plane. So this is going to be the px. This one is got the py. Then you also have got this one, which is the pz. That's how the p orbitals are arranged. So you have some orbitals which are like this, some orbitals like this, some orbitals like that. So it has got planes. That is the p orbital, and we say that it resembles the clover leaf. So it's saying the p orbital which determines the character of an atom is directional, non-directional, horizontal, vertical, diagonal. So it is directional. Direction for the fact that you are able to tell that a particular orbital is in the y-axis, a particular orbital is in the x-axis, a particular orbital is in the z-axis. So it is directional. Horizontal, that is the x-axis, vertical, the y-axis, diagonal, the z-axis. So it has direction. So it is directional. That is so the answer there is option 1. 9. An atom with 5 protons, 6 neutrons, and a charge of 3 plus has an atomic number of. So you should understand, let's call this particular atom as Z. So we're saying that this particular atom has got 5 protons. So 5 protons, the number of protons is equivalent to, we said that is equivalent to the atomic number of that particular atom. So now in this case, we are saying that this particular atom has a charge of 3 plus. What does a positive charge mean? A positive charge, it means that that particular atom has lost electrons. So this particular atom has lost how many electrons? 3. That is what it means, 3 plus. 3 minus, it means a particular atom has gained. So we are saying that an atom with 5 protons, 6 neutrons, and a charge of 3 plus has an atomic number of. So atomic number is equivalent to the proton number of an atom. Therefore, the atomic number of this particular atom has to be 5, which is equivalent to the number of protons of that particular atom. Those charges have got no effect on the atomic number of an atom because the number of protons is not affected. What is affected is the number of electrons when an atom loses or gains electrons. So, option 1 for question 9. 10. Almost the entire mass of an atom is concentrated in the. So, the mass of an atom in the nucleus, what makes up the mass of the atom is the number of protons plus neutrons. So, where do we find these? Protons are positively charged. Neutrons do not have a charge. So when you add these two, these are what are going to give you what? The mass number of an atom. So where do we find the protons and neutrons? These are found in the nucleus of an atom. Hence the answer has to be nucleus. The entire mass of an atom is concentrated in the nucleus because that's where you have neutrons and protons. For you to get the mass number, you are supposed to add number of neutrons and protons of that particular atom. 11. How many orbitals are completely filled with electrons in an atom of phosphorus in the ground state? How many orbitals are completely filled with electrons in the atom of phosphorus in the ground state? So we are supposed to use the ground state. So the ground state is like this. First of all, what is the atomic number of phosphorus? So phosphorus atomic number is 15. So we know that we are going to have, we have the 1s, the 2s, 2p, then we have 3s, 3p, and 4d. I can end there. So we will start filling until we finish all these 15. So the 1s, we said that this one can only take up how many? Can only take up 2 electrons, a maximum of 2 electrons, because it has got 1 orbital. This one will also take up 2. Then this one will have a maximum of 6. This one will have a maximum of another 2. So that is 6 plus 6, we have 12. Let me add one more. So this will be 4s, then 4p, 4d. Okay. Then how many are remaining now? So we have 2, 4, 6 plus 6, 12. So from 15 we have 3, like that. So this one, you should know how to come up with the electronic configuration. You feed like this. Okay. You feed them like this. Then these like that. Next is going to be this one. Next is going to be like that. That's what you follow. So you go like this for you to come up with the ground state electronic configuration. So the question there is how many orbitals are completely filled with electrons in the atom of phosphorus? So here we know to say that where you have 6 on the p, that is the maximum. So this one will be completely filled. On the s, when you have 2, that is also maximum. So all the s will be completely filled. These ones will also be completely filled. But the 3p, this 3p, we say that it has got 3 orbitals. So if you have 3 electrons, you have one here, another one there, another one there. Because we are filling using the Aufbau principle. You first have to fill one in each. So all the 3 are done in this one, meaning that the 3p will not be completely filled. So how many shells are going to be, how many orbitals are going to be completely filled? So we have, let's start counting. We'll count from this one is completely filled, this one, that one, and this one, except that one. So how many orbitals do we have? Well, we have 3s orbitals there. So 3 multiplied by, okay, so we have 3 orbitals, because each of the s orbitals has got a single orbital. 1, 2, 3. So I'm done with these. Then we have another p. So p, we say that's got a 3. That one will be completely filled. So 1, 2, 3. So how many are going to be completely filled? How many orbitals are going to be completely filled? 1, 2, 3, 4, 5, 6. 6 are going to be completely filled. Then 3 will not be completely filled because 3 are coming from this. So the answer there has to be 1, 2, 3, 4, 5, 6. So 6 orbitals of phosphorus are going to be completely filled, and it's there. So the answer is A. Oh, sorry, option 1. 12. What is the total number of s electrons of chlorine with 17 electrons? So in this case, we are just interested in the s shells of chlorine. So we're also going to use the ground state. So you should know how to come up with a ground state. You start with this 1s, next it will be 2s, then you have 2p. After that, you're going to have 3s, then 3p, then 4d. After this, you are going to have 4s, then 4p, 4d, and 4f. I'll end there. So remember, we have 17. So 17 are filled 2 there, another 2 here, 6 here, another 2 there. How many are remaining? So we have 12. Because 1, 2, 3, that is 6, plus another 6, 12. So from 17, how many are remaining? So 5. So 5, those 5 are going to be in the P. So we have 5 here, like that. If you count here, you have 17. So the ground state electronic configuration of chlorine is going to be 1s, then 2s, 2p, 3s, and 3p. So this will have, you are counting like this, then you come here, the next it will be this, so 2p, the next it will be this, like that. So 1s, 1s, 2s, 2s, then 2p, 2p, then 3s, 3s. Next is going to be 3p, then 4s. So we don't have the 4s, that's why I'll end there. So this has this will have 2, this one 2 as well. Then the p will have 6, this one 2, then the remaining this will have 5. So how many of the s orbitals are completely filled? 1, 2, 3. So we have 3 atomic orbitals, 3 s sub-levels are completely filled. What is the total number of s electrons for chlorine with 17 electrons? So we have 3 s orbitals, s sub-levels which are completely filled. So since each s atomic orbital can take up a maximum of 2, that to be 2 multiplied by 3, so the answer will be 6. So we have 6 there as the answer. 13. How many orientations would a p orbital have in space? So I explained this already. You have the px, py, and pz, so it's 3. You have 3. Then 14. How many valence electrons does an atom with a Z of 11 possess? So here now they're asking about valence electrons, not valence number. So valence electrons. So Z, that is atomic number. So this particular atom has got atomic number of 11. So you are supposed to come up with the electronic configuration. That would be 2,8. So 2 plus 8, 10, then 1. So this will be the valence electron number, which is just going to be 1. So that's the answer there, 1. If they ask about the valence electron in this case, or the valence number, it was still going to be 1, because 1 is less than 4. So we are not going to subtract, we just get it the way it is. 15. How many valence electrons that the following atom has? So we are just supposed to add these. Electrons and know how the total number of electrons that we have. Then we can come up with a normal electronic configuration and check how many the valence electron. Or okay, so let's do that. That I think is going to be the easiest. Let me not confuse. So I have 2, 4, 4 plus 6, that is 10, 12, 12 plus 6, that will be 18, 20. So this has got 20. So that is 2,8, 8, that is 8 plus 8, 16, 18, so another 2. So the question here is, how many valence electrons does the following atom have? So it has 2 valence electrons. So the answer is 2. Atoms in the outermost shell, those are what we call valence electrons. So we have 2 electrons in the outermost shell. So that's the answer. Then 16. Water molecules are held together by dash in a water body. So water molecules, you know that each water molecule has got a shape like this. On this water molecule, you have you are going to have oxygen is partially negatively charged. Okay, it has got 2 charges. These are positively charged. So if you have got a water molecule, you are going to have another water molecule here. Okay. So this one will also be partial negative charge, this partial positive charge. So there's going to be an interaction between this hydrogen of one water molecule and this oxygen. If you have another water molecule here, this oxygen is partial positive charge, so it will also be attracted to this water molecule. So the question is, water molecules are held together by, so this bond which exists between one water molecule to another, this bond is what is known as hydrogen bond. So water molecules in a water body are held together by hydrogen bonds. Whereas within a water molecule, that is just one water molecule, these atoms are held together by, these are covalent bonds. So water molecules are held together. Water molecules, that is, you have got a number of water molecules, so they are held together by these weak hydrogen bonds. So the answer is hydrogen bond. But if the question was to say within a water molecule, you would have been considering these bonds. Covalent bonds was going to be the answer. That is even the reason why hydrogen bonds between one water molecule and another, I'm showing them in dotted form. That is to show that they are weak as compared to these, which I'm showing in a solid form. Covalent bonds, they are very strong. So when you warm a water molecule, the bond that breaks are the hydrogen bonds and not covalent bonds. 17. Identify the false statement. So we have 5 statements. 4 of them are correct, then one is false. So we are looking for that false statement. A is saying water adheres to the surface of its container. That is true. So if you have a glass of water and you fill this glass of if you fill this glass with water and you decide to pour the water out of this glass, you are still going to remain with some water which will stick to the glass. And this force which makes this water to stick to the glass is the adhesive force. So it's true, water adheres to the surface of the container. 2 is saying water conducts electricity. Water is a good conductor of electricity, which is true. Water can dissolve proteins. Water can dissolve proteins. So what can water not dissolve is those molecules which are hydrophobic. They cannot dissolve in water, like cooking oil. So proteins, we have the phosphor, we have peptide bond there. So can those dissolve in water? True, yes, they can. So proteins can dissolve in water. They have an ability of dissolving in water. Proteins can dissolve in water. 4. Water sticks to a glass because of cohesive forces. So when explaining option 1, I said that what makes water to stick to a glass are adhesive forces, not cohesive. Cohesive forces, these are forces which makes water to stick together. Like molecules, like this water molecule to stick to another water molecule, the force that has to exist there is what is known as a cohesive force. But for this water molecule to stick to a different molecule, that is a glass in that matter, they have to be different forces, so adhesive forces, not cohesive forces. So option 4 is a false statement. Water moves along blood vessels because of cohesive and adhesive forces. That is true. So for a water molecule to move in a capillary tube, they first has to be cohesive forces. That is, water molecules themselves, they have to stick to each other. Then at the same time, now these water molecules, they have to stick to what? To the wall of that capillary. So those forces are going to be adhesive. Whereas within the water molecules, those forces are what? Are cohesive forces. So both have to exist for it to have a capillary action. 18. Water bodies in a lake and oceans have constant surface temperature because, so why is it that water bodies in a lake have got constant temperature? Their temperature does not change. What property of water makes them so? This is question 18. So A is saying because water freezes at 4 degrees Celsius, so not really. Like why does you know that an ocean is a very big body of water. The sun in the sky is able to, the heat reaches the surface of the water in the lake, but this water will not change its temperature. What makes it so? So it's because it takes a lot of energy for a water molecule, for water to change its temperature. So it requires a lot of energy for a temperature of water to change. That is the reason why a water molecule maintains in a lake, a water body in a lake maintains a constant surface temperature. So it's the amount of energy that is required to, high amount of energy is required to change the temperature of water, and that property is what is known as high specific heat capacity. So high specific heat capacity is what makes water not to change its, in a lake or a water body not to change its temperature, to have a constant temperature. High latent heat capacity, this is the amount of energy that is required to change 1 degree, to change 1 gram of water per 1 degree Celsius. That is the amount of energy that is required to change 1 gram of water per 1 degree Celsius. So high specific heat capacity, that is the amount of energy that you need to change the state of water from, say, from liquid to gas. So because of high specific heat capacity, lake and oceans have got a constant surface temperature. 19. When oxygen combines with hydrogen to form water. Okay, 1. There are two lone pairs of unshared electrons. This is true. That is what I was explaining. Oxygen is going to have two lone pairs of unshared electrons like this. And these are what brings about partial negative charges on oxygen molecule. That is true. 2 is saying there is one lone pair. So there is one lone pair of unshared electrons. So we said this is a lone pair, this is another lone pair. So there are two lone pairs. There is not one lone pair. So there are two lone pairs. So 2 is false. Ionic bonds are formed between oxygen and hydrogen. So we have covalent bonds, not ionic bond. Then develops a positive charge. So oxygen develops a partial negative charge, not a positive charge. What would develop a positive charge? A partial positive charge is going to be hydrogen. Then covalent bonds are formed between hydrogen atoms. So covalent bonds are not formed between hydrogen atoms. They are formed between oxygen and hydrogen atom. This is the covalent bond. So the correct answer with regard to water molecule is that there are two lone pairs of unshared electrons. Option 1 for question 19. So that's the answer to question 19. Then 20. The bonds that were broken when water vaporizes are dash bonds. I explained this. I said it is the hydrogen bonds which break when you boil water molecule. The reason why the covalent bonds do not break is because those are strong bonds as compared to hydrogen bonds. 21. Sucrose is a non-reducing sugar because the dash of its fructose ring and the dash of glucose ring are not free. So you have you're going to have a glucose which looks like this. Then a fructose, it is like this. It has a pyranose ring, or a furanose ring. This is fructose. This is going to be glucose. So this is going to be carbon 1, 2. Here we are going to have carbon 1 will be somewhere here. Then this will be carbon 2. So the reason why sucrose is a non-reducing sugar is because dash of its fructose, so carbon 2, this carbon of fructose ring and that of glucose ring are not free, and that of carbon 1. So carbon 1 and carbon 1 of glucose and carbon 2 of fructose ring are not free. Hence sucrose is a non-reducing sugar. So it has to be 2 because fructose is coming first. So 2, 1. Carbon 2 and carbon 1 of glucose. So C21. So that C2, C1. Option 2 for 21. And for this bond to be formed, sucrose has to turn 180 degrees. It has to turn 180 degrees for that bond to be formed between a carbon 2 of fructose and carbon 1 of glucose. The fructose has to turn 180 degrees for that bond to be possible. 22. Identify the asymmetric carbon atoms in the molecule below. So asymmetric carbon are also known as chiral carbon. So what are these? So a chiral atom is an atom which is linked to 4 different functional groups or atoms. Let's say if we have that carbon as a center atom, that is a chiral atom or asymmetric atom. So in this case, it's a carbon. So we are going to have this carbon at the center. Let's say if this carbon is linked to 4 different functional groups, let's say A, B, C, and D. All these are different from each other. Say D. All these are different from each other. We are looking at the functional groups which are linked to it. They are all different from each other. So this carbon atom is going to be said to be what? A chiral or asymmetric carbon. But as long as you have two which are not the same, let's say this is also C. So you have C here, another C there. This is not linked to four different functional groups or atoms. So it's not a chiral carbon. That is what we are looking at when we say a particular atom is asymmetric or is a chiral atom. So here we are saying that a particular atom has to be linked to 4, not 3, and 4 these have to be different. So 1 already can't be a chiral carbon because it's just linked to 3. Let's check 2. So 2 is linked to hydroxyl group, this group, that group, and this group. All these are different from each other. So 2 is a chiral carbon. Then this one is linked to hydrogen, hydroxyl, this group, and that group. They are also all different. So carbon 2 and carbon 3, they are chiral carbons. This one will not be a chiral carbon because we have hydrogen here, another hydrogen there. So it's not a chiral carbon. So only 2 and 3. The last one, also you have this one, that one can't be a chiral carbon. So only 2 and 3 are linked to 4 different groups. So the answer has to be 2 and 3. So option 5. That's the answer. 23. So we have 23. 23 reads, identify the sugar or sugars that does not or do not have the empirical formula this. So carbons or molecules which have got that empirical formula, they are carbohydrates or they are monosaccharides. Monosaccharides are the only molecules, they are only sugars which have got this chemical formula. So lactose is not a monosaccharide, so it can't have that chemical formula. Deoxyribose has. Deoxyribose is, yes, it's a monosaccharide. Glyceraldehyde is a monosaccharide. Glucose is a monosaccharide. 1 and 2. 1 is not, so this can't be the answer. So the answer here is lactose. Lactose is a disaccharide, so it cannot have this empirical formula. Only monosaccharide. Then where is 25? This was 23. Then 24. Carbon of glucose combines with carbon of the same glucose open chain to form a pyranose ring. So you're going to have 1, 2, 3, 4, 5, 6. These are the carbons. So which of these carbon combine with another carbon to form a pyranose ring? Carbon 1 attacks carbon 2, carbon 1 attacks carbon 3, carbon 1 attacks carbon 4, carbon 1 attacks carbon 5, carbon 1 attacks carbon 6 to form a pyranose ring. So the correct answer is carbon 1. This will be 1, 2, 3, 4, 5, 6. It's this carbon, the carbon that is next to the last carbon. This one will attack carbon 1 to form a pyranose ring. So it has to be carbon 1 and carbon 5. So option 5. If you want to know more about this, the pyranose ring and furanose ring, you should watch our videos on carbohydrates. This is where we explain. 25. Identify the functional groups in carbohydrates. So what are functional groups? Functional groups, these are molecules that gives chemical characteristics of a particular molecule. So alcohols, these are what? Hydroxyl groups. Alcohols and carboxyl groups. So carboxyl group is this group. So we don't have this group in carbohydrates. We only have this group, which is a carbonyl group and not a carboxyl group. So not 1. 2 is saying aldehyde and ketone groups. So aldehyde and ketone groups, it's this same group, but it just depends on where it's going to be. If it's at the first carbon, it's going to be a ketone. If it's at any of the carbon, not the first or the last, it's going to be what? If it's at the first carbon, it will be an aldehyde. If it's just on any other carbon, let's say carbon 3, carbon 4, carbon 5, it's going to be classified as ketone. So yes, it is a functional group. 2. Then hydroxyl group and amine. Amine is the NH2. We don't have this group in carbohydrates. 4 is saying carbonyl group and hydroxyl groups. So carbonyl group is this group. Hydroxyl group is this group, like that. So indeed, these are alcohols. At the same time, they are what? They are hydroxyl groups. So 2 and 4. So 2 and 4 aldehyde and ketone, yes. 4 carbonyl and hydroxyl groups. So the answer will be option 5, which combines all of them. So that will be the answer for question 25. 26. 26. The cellulose microfibrils are held together between adjacent chains by hydrogen bonds. So the cellulose microfibrils are held together by hydrogen bonds. So the answer is this. Even this is also well explained in that topic. So if you want to learn more, you can also just check out our video on carbohydrates. Then we have CH3H8O2 ether. This is a triose. Triose for the fact that it has the 3 carbons. To be a triose for the fact that it has 3 carbons. 4, this is going to be 4 is going to be quad. Then 5, it is pent. 6, it's a hex. So just like that. So triose is a carbohydrate which has got 3 carbons. And you know that all sugars will end in OSE. In biology, everything which ends in OSE, just like enzymes ASE, in biology, that everything that ends in OSE, that is a sugar. So the answer here is option 5. 28. Beta fructose must 10 degrees in order to make the 1,2 glycosidic bond in sucrose. Exactly what I explained on that question. So I said fructose has to 180 degrees to make that bond possible. So the answer here is option 4. Is it 4? So the answer there, yeah, it's option 480 degrees.